Hello everybody, today we're going to look at something called the dot product. It's another operation that we can perform on vectors and how that relates to the angle between vectors. Alright, so the dot product is described here. So we have two vectors, either in component or linear combination form, and it is denoted as u dot v. So that's not u times v, it's u dot v. So it ends up being just a real number. For a dot product, you won't get another vector. You'll just get a real number. So it's the product of the two first components plus the product of the two second components, AC plus BD. All right, so let's get a little practice with this. So it should be relatively straightforward. So if this is our vector for u, and v is this vector in linear combination form, which remember in component form is just -2, 4. To get u dot v, we would do a times c. So if this is AB, this is CD. So we do a, so 3 times c, -2, plus b, -7 times d, 4. Simplify that, you get -6 plus -28. So u dot v is -34. Next, we are going to do v dot u. So now we go backwards. Now we're going to do CA. So -2 times 3 plus dB, 4 times -7. We still get -6 plus -28, which is -34. So these two first examples kind of show you that dot product is commutative. So you can flip the order of it and you should get the same answer. And then u dot u is basically just saying we're going to do the vector 3 times -7, or sorry, 3 -7, and dot product that with itself. So essentially what that means we're going to do is just a times a plus b times b, because you're just doing it by itself. So 3 squared plus -7 squared, so you get 9 plus 49, which is 58. All right, so that dot product kind of brings us into properties of the dot product. So if we have u dot u, like we saw on the previous slide, basically all you need to do there is take your magnitude and square it. So you're basically just adding the two components squared. U dot v equals v dot u, commutative. That's what the second one is, so commutative. And that means this is just a squared plus b squared. You can do dot product with a sum, so u dot v plus w. It does hold distributive properties, so you can distribute it. For a scalar multiple, there's a couple different things you can do with it. So k times u dot v is the same as that same scalar, k, times the whole dot product, or you can just multiply that scalar by the second vector. And then kind of similar to multiplication, 0 dot u is still just going to be 0. So the dot product can be used to find the angle between two vectors and to determine if two vectors are orthogonal, or what we call perpendicular. So orthogonal is just another word for perpendicular. The angle between two vectors is going to be between 0 and 180. So it's going to be the smallest measurement between those two vectors. So the measurements that are in blue there. All right, so let's start by looking at an alternate definition of a dot product. So the dot product, if you're involving an angle, is going to be the magnitude of u times the magnitude of v times cosine theta. So if you want to find the angle between two vectors, you're going to solve for cosine theta so that you can use that to help find out what theta is. So you're just going to divide by the product of the magnitudes. So this is the formula we're going to use to find the angle between two vectors. So if these are our two vectors here, -6, 8, and 6, 8, what you're going to do is set this up cosine theta equals the dot product of those two vectors, so negative 6 times 6 plus 8 times 8, and then all over the product of the two magnitudes. So the magnitude of u is going to be the square root of 36 plus 64 times the square root of 36 plus 64. So cosine theta is going to equal, let's see here, negative 36 plus 64 on the top is 28 over, this is the square root of 100 times the square root of 100, which will just be 100. Now we want to figure out what the angle is. So since we have cosine of theta, to find what the angle is, you are going to want to do the cosine inverse. So theta is going to equal the inverse cosine of 28 over 100. So make sure your calculator is in degree mode. We're finding these in degrees. So second cosine inverse of 28 over 100. You get that theta is equal to 73.74 degrees. So that means these two vectors, if you draw them out, the angle between them is going to be about 73.7 degrees. All right, so kind of using that as a guide, why don't you pause here and give this example a try? So try to find the angle between these two vectors. All right, so if you worked this one out, go ahead and check your work. So the dot product for the top, you should have gotten negative 13, and then the product of the magnitudes on the bottom, you should get square root of 290. When you take the inverse cosine of that ratio, you get 40.24 degrees. Now, one thing to try and not get confused, and sometimes for notation purposes, we go old school style here, and on the bottom, we'll use the kind of the old school multiplication symbol, especially since we don't have any x's usually involved with vectors. So just keep in mind, remember the top is u dot v, so you're doing the dot product there. And then on the bottom, you're multiplying the magnitudes. So make sure you try and keep those two things. Dot product on the top, multiplication or product of the magnitudes on the bottom. All right, so now that we know how to find angles between vectors, we're going to look at what it means to be orthogonal or perpendicular and how we can find that. The reason we look at perpendicular vectors closely is because it follows kind of some interesting properties. So if we're trying to figure out where cosine of theta equals, or we're trying to figure out basically what cosine of 90 is, to figure out what our cosine of theta should be equal to when using this dot product definition. So what we're really trying to look at then is, what is cosine of 90? Well, if you go to your unit circle, cosine of 90 is 0 degrees. So we're essentially looking where this dot product over the product of the magnitudes is 0. Well, in order for that to be 0, the top would have to be 0. So we're essentially looking where your dot product equals 0. So if you have two orthogonal vectors, that means your dot product will be 0. So u dot v equals 0. That's how you can tell if two vectors are orthogonal, aka perpendicular. So let's test it out. Are these two vectors orthogonal? So if you're asked if something is orthogonal, remember you're trying to see if the dot product equals 0. So let's find our dot product. So we're going to do a times c, so 2 times 9, plus d times b, so negative 6 times 3. So we get 18 plus negative 18. Lo and behold, that's 0. So since our dot product is 0, yes, these are orthogonal. Are these two vectors orthogonal? So I'm going to have you do this one on your own, but to help get you started here, let's get these into component form. So this is negative 2, negative 1, and then v is negative 3, negative 6. So go back and review how we found that in the last one, and then come back to this slide if you need to go back, and give this a try and see if these two are orthogonal. So hopefully as you went through this and once you paused, you saw that the dot product, -2 times -3 and -1 times -6, you end up getting 12. So that means these vectors are not orthogonal. So you could carry this further and then see what the angle between them is if you'd like a little practice of that. Otherwise, let's go ahead and move forward. All right, so we've done orthogonal vectors, so vectors that are perpendicular. What about vectors that are parallel? So vectors are parallel if the angle between them is 0 degrees. So you're going to want to make sure you keep straight that perpendicular or orthogonal means dot product equals 0. Parallel means that the angle between them is 0 degrees. All right, so you might want to, because they both involve 0, so you want to try and not get those confused. So suppose u equals 1, 2, and v equals 3, 6. Are these parallel? So based on what we know right now is we need the angle between them to be 0. So let's see what the angle between them is. Remember to do that, we use cosine theta equals the dot product of the two over the product of the magnitudes of the two. So cosine theta in this case equals u dot v. So 1 times 3 plus 2 times 6 all over the magnitude. So square root of 5 times square root of 9 plus 36, 45. So here we have cosine theta equals 3 plus 12 over square root of 5 times square root of 45, I believe ends up being square root of 225, which is 15. So here we get cosine theta equals 15 over 15. So cosine theta equals 1. All right, so since cosine theta equals 1, think of your unit circle. What degree measure is cosine theta equal to 1? Well, if you look at your unit circle, that should just be at 0 degrees. So since theta equals 0 degrees, we're going to say, yes, these are parallel. All right, another simple way to figure this out is if they're parallel, your corresponding components are going to be proportional, because if you think of this almost in terms of like slope, right? Rise over run. So our vectors, they're going to be parallel if they essentially have the same proportions of rise and run. So basically what you're going to want to be looking at then is if B over A equals D over C, right? Because if you think of these in terms of the horizontal and the vertical change over the horizontal change has to be the same among both, or they have to be proportional in order to be parallel. So let's try that idea with these two examples. So are these parallel? Well, let's try and see if they're proportional. So u is 2, 3, so we're going to do 3 over 2. And we're going to test and see if that is equal to 12 over 8. All right, so if we were to simplify that, I like to usually test using cross multiplication. 3 times 8 is 24. 2 times 12 is 24. Since we got the same answer, that means those are proportional. So then yes, these would be parallel. All right, let's try it with our next one. So this would be -2 over 6 and 9 over 0. Well, the nice thing here is we got something that's 9 over 0. So this right here is going to kind of be undefined anyway. So since these aren't going to have the same proportion, we can say not parallel. Now, if something's not parallel, you could try and go through and see if they're orthogonal, perpendicular, or what the angle between them is. We don't have to do that right now, but you could. Now, here's what you need to do. Determine if each pair of these vectors is parallel, orthogonal, or neither. What I always like to do is, since it's pretty easy to start, I like to test for parallel first because I just have to look at proportions, right? So first let's test if they're parallel. So we do 7 over negative 4 and see if that is equal to 7 over 4. Now, they would have to be the same sign as well. Since this first one is negative, then we know it's not going to be parallel. All right, so now let's see if the dot product is 0. So does u dot v equal 0? Do you guys remember what that means? That would mean it's orthogonal. So let's test that next. So we're going to do negative 4 times 4 plus 7 times 7. So we'd get negative 16 plus 49. I can already tell it's not going to be 0. That is actually equal to 33. All right, so now knowing that, we know it's not parallel, not orthogonal. It didn't ask us to find what the angle is between them, so we can just say neither. All right, so for these next two, why don't you try that process? Test parallel, see if the dot product is 0, if they're orthogonal. If it's neither of those, you can just say neither. If you find out that it's one of them, then you can stop there, right? Because if things are parallel, they're obviously not going to be perpendicular and vice versa. So pause here, see if you can try that process with the next two sets of vectors. All right, so for the second set of vectors, right away, you found that they were parallel. The ratios were equal. And then the third set here, we found they were not parallel. Make sure you pay attention to those negatives. You would have gotten that 1 equals negative 1. Not true, so not parallel. Then test to see if your dot product is 0. As you multiplied, you found that yes, your dot product did equal 0. So then those are orthogonal. All right, so our last set of problems here is finding a value so that in one case, our vectors would be parallel, or in a second case, they would be orthogonal. So it's important to remember then how we find each. So for parallel, remember, we are trying to find the value that would make these proportional. So negative 2 over 1 would have to equal 6 over c. This is where your order is very important. You're doing the second component over the first component and then setting them equal. So then from here, we would want to cross multiply. So negative 2c is going to equal 1 times 6, which is 6. Then solve, divide by negative 2, you get c equals negative 3. So if this component here was negative 3, these would be parallel. To find out if they're orthogonal, remember, that's where your dot product is equal to 0. So the dot product of u and v is going to be 1 times c plus negative 2 times 6, and that would have to equal 0. So c minus 12 would equal 0. So to solve for c would have to equal 12 in order for those to be orthogonal. So kind of like we've been doing, pause here and see if you can go through using this next set of vectors. What would c have to be equal to be parallel? What would c have to be equal to be orthogonal? All right, so for those vectors to be parallel, c would have to equal negative 6. You can see the work that I went through there. And then to be orthogonal, c would have to be 121.5. So if you felt like you were getting the wrong answer there, you weren't. We just haven't dealt with numbers that big, but they can be that big. All right, so that should pretty much cover it. Give the 10.6a worksheet a shot. Try and do a few of those practice problems. If you feel like you're doing pretty well with those, go ahead and do your daily task on Schoology. Again, you get an unlimited amount of tries on those, so you can go ahead and give that a try. Until tomorrow, goodbye.